Daniel Bernoulli was a Swiss mathematician and a physicist of the 16th century. Bernoulli equation relates pressure, flow speed, and height for flow of an ideal incomprehensible fluid.
The Bernoulli equation is a statement of conservation of energy principle appropriate for the flowing fluids. The qualitative behavior that is usually labeled with the term Bernoulli effect is the lowering of fluid pressure in regions where the flow velocity is increased. In high velocity flow through the constriction, kinetic energy must increase at the expense of pressure energy.
When a fluid is in motion, it must move in a way that the mass is conserved, so that the velocity and the density are constant over the area. If the fluid is incomprehensible or the density is constant, we can make the assumption and relationship that area 1 times velocity 1 is equal to area 2 times velocity 2. The area times velocity is known as the volume of the fluid that flows through one section of the pipe. The research objective is to determine experimentally and computationally the range, the distance, versus the time of water coming out from the small hole located in an arbitrary distance from the bottom of a large cylindrical open container.
Procedure. First, you need to measure the diameters of the big hole on top of the cylinder and the small hole on the bottom. This in order to calculate the areas of both. Then you need to measure the height from the floor all the way to the top of the cylinder and from the small hole to the top of the cylinder and calculate the volumes of the cylinder. Then fill all the cylinder with water all the way to the top. Then release the water flow, the stream through the small hole, and calculate everything in Excel. Measure how much it takes for the cylinder to go empty with a chronometer and the maximum reach of the stream. Settings. We used a cylinder made out of a PVC pipe with a volume of 3.65 liters, considering a height of 41.5 centimeters. The experiment was executed on outdoors and the cylinder was placed on a small bench, giving a total height of 84 centimeters. Theory and data. We used the following equations. For range equals 2 times the square root of the height from the hole all the way to the top times the difference between the total height and the height from the hole to the top of the cylinder. Then we used a formula for velocity, which is velocity equals the square root of 2 times gravity times the height from the hole to the top. And we used a equation in order to calculate the volume that flew through the hole. That is, the volume equals the area 2 of the small, which is the area of the small hole, times the velocity. And in order to calculate the remaining volume, it's the total volume minus the volume that went out through the hole. For the results, we can say that the data obtained theoretically with the calculations and with the experiment are very consistent, and as they have really similar data.
As our recommendations, we could say that the experiment should be executed in a place where there is no air, wind, and in order to calculate correctly the distance of the fluid, and we should measure very precisely the diameter of both holes, because it can lead to extreme errors. We carry out the experiment correctly. We use the continuity equation and the Bernoulli equation to determine correctly the range of the fluid per second.